And here is a test. It's a very simple and crude test used to detect the presence of heavy metals in water. Heavy metals could be things like copper, iron, nickel, chromium, lead, mercury, silver, and so on and so forth. And this test is not quantitative in the sense that it doesn't tell you how much heavy metals you have there, but it does tell you that you have heavy metals in a certain sample of water. So if you suspect that you have high amounts of heavy metals and things like well water or so on and so forth, it's a very good way to test to see if you actually do have them present. And different heavy metals behave differently with this reagent, which is simply caustic soda sodium hydroxide. So if you add concentrated sodium hydroxide to water, you expect to see this color change. Here's our control. There's no heavy metal there. And we do not see any color change essentially, which tells us that it doesn't contain any heavy metals or high amounts of heavy metals. And the first one here gives us a deep blue color right away, and that's an indication of the presence of high amounts of copper in that water sample. Again, the next one gives us another deep blue color. That also is copper. I would like for you to just pay attention to both of them and tell me which one you think has a deeper blue color, which is indicative of higher amount of copper in the sample, comparatively speaking. And then we have two other ones that have a sort of a reddish color to them. That could be presence of heavy metal. That could be just mud as well. So it's not always that color indicates there's something there. But we have to put it to the test to see, and clearly you see a deeper color. And the important thing is that the so-called PPT, precipitates in chemistry. It's not just color. You form precipitates with sodium hydroxide when you have heavy metals in water. And you can see clearly that indicates there's heavy metal there. And that color, the deep red color, is indicative of the presence of iron 3. Iron has two oxidation states, iron 2 and iron 3. Iron 2 tends to be brownish in color. Iron 3 tends to be reddish in color. And that's a clear indication of the presence of iron 3 reacting with sodium hydroxide. And again, you see the same reaction here. You have to pay attention to the fact that I am using exactly the same amount of sodium hydroxide for all of them. So in that case, the depth of the color is directly proportional to the amount of heavy metal present in that water sample. So as you leave this to sit for a little while, you will see that the depth of the color does increase for each of the samples except for the control that does not have any heavy metal or high amount of heavy metal, at least that we know of, present in it. So that's your control. That's your first copper containing sample. That's your second copper containing sample. That's your first iron 3 containing sample. And that's your last or second iron 3 containing sample. So in class, we're going to try to think through this. And I'll have you tell me which one you think has a higher amount of copper and iron respectively, based on the depth of the color and also the amount of precipitates formed. I'd like for you to take a closer look at this. If you go over there, so I can see that, you see the color you've formed, and this one you can see the color and also the amount of precipitates, which is that gooey kind of material you form in the solution. And here you can see much better with iron. It tends to separate a little bit from water called precipitates, the gooey kind of material. It's a new compound formed when sodium hydroxide reacts with an iron 3 compound. And finally, the last one here clearly has also a lot of gooey material as well. So in class, we're going to try to work through which one you think might have a higher amount of copper and iron respectively.